Hey guys, it's Mr. Grady. Let's take a look at what we're going to learn today at your edition of CMA Math Academy. So, what are we learning, why are we learning, and how will we know if we have successfully learned it? So, you will be able, when you leave today, to apply the Pythagorean Theorem on a couple different things. So, one on a coordinate plane, so a graph, and then also with three-dimensional figures, 3D shapes, 3D figures. Why are we learning this? So we've already learned the basics of Pythagorean Theorem. Last week on Monday, we had like the basic video. On Wednesday, we had Mr. Schrag's amazing real-life example video. Now it's time to apply our learning to other situations, which again would be on a graph, a coordinate plane, or in 3D figures. Then how will you know if you've successfully learned everything you need to? So when you're given 2 points on a coordinate plane, you're going to use the Pythagorean Theorem to determine their distance from each other. Also, when you're given a rectangular prism, which is a 3D shape, kind of looks like a box, a rectangular box, you're going to be able to determine the diagonal length of that 3D figure. Okay? So let's go ahead and let's get started. Now, I got to be honest with you, my plan for today was to start off class with a joke about dogs. You know, we've been doing all these dad jokes. So I was going to start off with a joke about dogs, but then I realized it might be a little bit too far-fetched. So yeah, just let that kind of sit there for a second. All right, so now that that amazing joke has really had a chance to soak in, I know you're going to tell your friends about that one. Let's go ahead and let's get started. You're going to be on M493 today, so I'm going to give you a second to get to M493. Hopefully these pages are torn out. Give you a second to get there. Okay, and then now that we're all there, let's go ahead and we're going to read this top paragraph together. Again, when I stop, you're reading the next word. We're a team. We all read together, helping each other out. Our title here is Applying the Pythagorean Theorem to determine the distance on a coordinate plane, and we talked about that in what we were learning today. So as we go through this, we need everybody reading, everybody participating, helping us out, okay? So if we start with the word the, so it says the 1, 2, and 3, 7 are on the coordinate. You can calculate the between these two by drawing a triangle. When you think about line segment as the, one more time, say this word again, of the right, you can use the Pythagorean theorem. Okay, so it's just telling us that these 2 points here, 1, 2, and 3, 7, they've already put them over here on the graph for you. Okay, so I formatted mine just a little different to fit everything on one screen. It's down below for you, but you have this on your screen. So we're saying 1, 2 is over 1 up 2, and 3, 7 is over 3 up 7, and we've just got our 2 points. So it's telling us we can use the Pythagorean theorem to figure out how far these two are from each other. So there's 2 things I want you to add to this before we start. Okay, so first of all, somewhere, just remind yourself that in an ordered pair, x comes first, then y. Remember, x tells me left and right, so I was going right 1 or right 3, and then y tells me up or down. So in this case, it was right 1, up 2, and that's how I got that first point. Right 3, up 7. That's how we got our second point over here. The next thing I need to make sure we have, so find a place to write this down on your book, is we can count vertically and horizontally on a graph. That is okay. So here's what I mean by that. I could count up or down. That's okay. I can count straight across, right or left. I can count that. That is totally fine. But what we cannot do is we just can't count diagonally. So what I mean by that is if I was going to count from my point to my other point, I can't just count, well, this kind of looks like 1. If I keep going, it's kind of another 1 and another 1. Oh, that might be a box right there, and count it diagonally. It doesn't work that way. So you're going to be able to count up, count over, just can't count diagonally. Okay, so now that you've written that down, let's actually do this problem. So, all right, so we've got our graph here, and let's go through and let's look at the directions real fast so we know everything they want us to do. So the first thing it says is to calculate the distance between the 2 points shown. So we've talked about that. We're trying to find this distance here. Now, we can't just count diagonally. We can't just go 1, 2, 3, 4. You know, we talked about that earlier, so that's not going to work. Let's go to A and see what A says. It says, connect the points with a line segment. So let's start with that. Let's go ahead and let's connect our 2 points with a line. So take some straight edge, take your ID, and we're going to go ahead and we're going to connect our 2 points with a line. All right, so we got our first part down. The next step says draw a right triangle with this line segment as the hypotenuse. Okay, so what it's saying is if you think back to slope, remember to calculate the slope of a line we count up and then over. That's exactly what you're doing here. We made that triangle. We practiced that a lot. So we're going to count up and we're going to count over and we're going to draw that triangle. So I'm going to draw mine while you draw yours. So I'm going to draw my line up and I'm going to draw my line over. Okay, and I end up with a triangle that looks like this. Let's go down to B. B says determine the lengths of each of the legs of the right triangle and then use the Pythagorean theorem to determine the hypotenuse. Round your answer to the tens place. So we're going to go ahead and we're going to count this, but as we do, we have to be careful because if we notice, every two boxes over here is actually one number. So even though we're counting 1, 2 boxes, that's only one amount. Same thing going across on our x-axis, they're counting by twos. 2 boxes is one amount. So let's count this out. So really every 2 boxes is 1. So we've got 1, 2, 3, 4, and 5. So we know the vertical measurement here for our leg is 5. Okay? If we go up to our top part of our triangle as we count horizontally, we're going 1 and then 2. And again, that's because they're counting by 2. So it's 5 up, but it is 2 over. So I'm going to give you a second now. We've done a lot of stuff with Pythagorean theorem. I want you to go ahead and I want you to solve for C. So take a second and find what C is. All right, so let's see how we did. Now remember, what we've done is we've created this right angle in the corner, and if we draw our arrow across, that's how we figure out that this missing side is C. So that tells us that our other two sides should be A and B. Now again, from previous work, we know it doesn't really matter if 5 was A or 5 was B, as long as C is in the correct spot. So we're just going to go ahead and we're going to fill in our equation. Remember the equation is A squared plus B squared equals C squared. So we know that A on mine was 5. Now if you had 2 in that place, that's okay. So if your numbers are switched, remember that's totally fine. And that's going to equal C squared. So I need everybody's help here. So everyone's going to tell me, what is 5 squared? So 5 squared should have given us 25. Again, I need everybody's help. What's 2 squared? So 2 squared is 4. And that's going to equal C squared. So as we know, we're going to combine our constants. So again, everybody help me out. What's 25 plus 4? And we should have gotten 29 as our answer. So we know this, again, from all of our work. So you're going to help me one more time here. And you're going to tell me, what is the inverse operation of squaring a number? All right, so we should have said square root. So we're going to square root 29 to get our answer. Now if I square root 29, I get this decimal. And it keeps going. There's some numbers after 5, 1, 6, and so on. But we're going to stop it there. And the reason I wrote all this out is I know it says round to the 10th, but I had a lot of questions last week about rounding, so let's talk about that. So the tens place right now is this 3. In order to decide what to round it to, we actually look at the hundreds place, so that's where the 8 is currently. So this 8 actually determines what we do with this 3. So if our number is 5 or greater, so we have 8 in the hundreds place. If we had 5 or greater, that's going to bump this 3 up to a 4. If it's less than 5, it stays a 3. So for us, this 8 actually bumps our 3 up to a 4. So we end up with 5 and 4/10 as our value for C. Okay, so what that's telling us is over here on our triangle, the hypotenuse value is 5 and 4/10. Okay, so let's go on to page M494. We're going to talk just for a minute, and then you guys are going to work from there. All right, guys, so page M494 has 2 problems on it, and then 95 has 2 problems on it. So let's look at the top of page M494. So let's go through the directions real fast. It'll be pretty much similar to what we did on the page before. So it says determine the distance between each pair of points. Round your answer to the nearest tenths place. So again, we're trying to find the distance diagonally between these 2 points. The only major difference in this problem is they haven't put our points on our graph for us. On the previous page, the points were already there. As you can tell from these next 4 graphs that you're going to be filling in, the points aren't on there already. You're going to have to put the points on the graph. So real quick review. Remember, like we talked about on the previous page, that our x value comes first, So this first number is our x value. Second number is our y value. So x is 3, 4 is y. Same thing over here. 6 gets the x and 8 gets the y. Remember that the x tells us left and right, and the y tells us up and down. Same thing over here with 6 and 8. So I'm going to be going right 6 and then up 8 when I put my points on there. Okay. So you're going to put these points on the graph. After you've put the points on the graph, you're going to go ahead and draw your two legs. So you're going to count it just like we would slope. You're going to connect your diagonal and use your two legs to find the slope of the diagonal line. So I want to draw your attention to one thing before we work. Again, if we look at our x and our y axis, every 2 boxes is counting as 1. So even though you're going 2 boxes up, it's just 1. 2 boxes up, again, you get to 2. Same thing going on our x-axis. So just be careful as you're counting. So you're going to do question 2 here, 2a. After 2a is done, you're going to go on to b, c, and d. Again, before we start working, I want you just to notice that on the rest of these 3 graphs, they're counting by 1s. So the first graph you do is counting by 2s, but then you go back to every 1 box is just 1. So like on B, it's 1, 2, 3, 4, 5, 6. Same thing on C, 1, 2, 3, 4, 5, 6. And same thing on D, 1, 2, 3, 4, 5, 6. So it's kind of tricky because they bounce back and forth, but just watch what they're counting by. And then in a minute here, you're going to be sharing this with your table partner. So I'm going to give you a few minutes to work, and then we'll share. Ready? Go. So now that we've had a chance to work, we're going to go ahead and share our answers with our table partner. So as we walk through this, you're going to explain your answer to your partner. So it's not just, oh, my answer was 5. It's how you got it. What did you get for the legs? How did you draw your triangle? How did you use that to find the hypotenuse? So if you're table partner number 1, you're doing problems A and C. A and C. So that's partner number 1 doing A and C. If you're partner number 2, you're explaining B and D, and then we'll go over the answers as a class really fast. Okay? So 1s are doing A and C, 2s are doing B and D. Ready, share. So now that you've had a chance to share with your partner, let's go back and let's check how we did. So for 2A, here's how our triangle should have looked when we graphed it. We have legs of 4 and 3, which leaves us with a hypotenuse of 5. So C should have equaled 5 on 2A. If we go through B, C, and D, you can see our answers up above. So B gave us a hypotenuse of 4 and 4/10. C gave us a hypotenuse of 8 and 1/10. And then finally, D gave us a hypotenuse of 2 and 8/10. Okay, so now that we've talked about graphing to find C using a coordinate plane, remember that was part of what we were going to learn today. Let's get into the second section of what we need to learn today to be successful. So for our next objective of the day, we are going to kind of be jumping around a little bit. So the first page I want you to find is page M4-107. So I'm going to give you a second to go to M4-107. And once you've found that page, I want you to skip down to question 2. So question 2 gives you these 2 different figures and asks you to compare a 2-dimensional diagonal to a 3-dimensional diagonal. But importantly, it says describe the similarities and differences. So what I want you to do is just looking at these 2 figures, what are some similarities about those 2 figures? What are some differences about these 2 figures? This doesn't have to be in a complete sentence. This can just be a list. But you can see down towards the bottom on mine underneath, I just have similarities and differences written out. And I'm going to list some here in just a second. But I want you guys to take a second and do this first of all. So go ahead and come up with as many similarities and differences between these 2 shapes as you can. Go. So now that you've had a chance to list your similarities and differences, we're going to partner share this. Partner number 2, you're going to go first, followed by partner number 1. If your partner lists something that you don't have, you're going to add that to your list. So anything that they say that you don't have on your list, we're going to add that up and see what we get. Okay? So again, partner number 2 starting us off. Go ahead and start. So now that you've had a chance to write your own and brainstorm, and now you've had a chance to share with your table partner and add anything you didn't have, let's look at some of the similarities and differences that I came up with, and we'll compare this to what you had. So let's start with my similarities. The first similarity I found was that they both have a rectangular shape. So our shape over here is obviously a rectangle, and then this shape, our 3D shape, still has a rectangle as well. The next thing I found is that they're the same size rectangular face. So here's what I mean by that. This rectangle here in the two-dimensional, this face, that's what we're going to call it, this side, this face, or this plane, either way, is the same size rectangle as this front-facing plane is on our other rectangle. Okay? The next one is they both have a diagonal line. So in our first shape, we have a diagonal line going from top to bottom. Same thing over here, we have another diagonal line going from top to bottom. And then you might not have had this one because we haven't talked about this yet in the three-dimensional, but you can use Pythagorean theorem to determine that length of a diagonal line. So we've talked about it in a 2D figure a lot, that we could find this height in the base, a squared and b squared, and use that to get c squared. The process is a little bit different here. It's not quite as simple, but we could still use Pythagorean theorem to get that diagonal line. Okay, now here are some differences. The main obvious difference is one is two-dimensional, meaning it's flat. One is three-dimensional. It has depth. It's going back. We see the shape on the left is four sides, a top, a right, a bottom, and a left. The shape on our right, the three-dimensional, is actually six-sided or six faces. So we have one here, two is this side, three is the top. But then again, there's a side over here, so that's four that we can't see. There's a back side we can't see is five, and then there's a bottom side or a bottom face or a bottom plane that makes it six. Okay, and then our 2D figure connects our line from the corner to a corner that's on the same face or the same plane, so it's on that shape. Where if we've noticed in the 3D shape, it starts in the front, but it actually ends up going to this back corner, or it starts in the back and ends up going up to the front. So it's a little bit different here when we look at our 3D shape. So far, like I mentioned before, everything we've done has looked like this first shape. It's been two-dimensional, and we've used Pythagorean theorem to figure out diagonal lines. Our 3D figure over here actually has a name, and we mentioned it earlier in what we were going to learn. A 3D rectangle is called a rectangular prism. Everybody say rectangular prism. So there's lots of different types of prisms. That's really just a fancy way of saying that it's three-dimensional. And then whatever this front face is, so for us it's a rectangle here and here, that's where they get the word rectangular, obviously. So if you see a 3D shape, it's not a box, it's not just a rectangle, it's actually called a rectangular prism. So that's kind of like a vocab word. Remember, every time we do these things, these lessons, we want to talk like mathematicians. So this is a rectangular prism because it has a rectangle shape, and then it's three-dimensional. That's where we get the word prism from. So let's go ahead and let's actually look at what we're going to do. So I want to give you another second here. Flip over again, and we're going to skip to page 109, and that's where the majority of our lesson is going to be. So I'm going to give you a second, just flip over to 109. So at the top it says practice with three-dimensional diagonals, and then our directions say determine the length of the diagonal for each rectangular solid. Now before we start, we've talked about rounding, and every time we round, we've been rounding to the tens place. Rounding to the tens place. And me and Mr. Schrag have talked about that a lot. Round to the tens place, round to the tens place. We talked about rounding a minute ago, looking at that hundreds place. As we go through these problems, and they're a little more complicated, there's a few rules for rounding that we're going to make sure we understand. So you have a little bit of room up here in the top corner. We don't want to take up too much room because we're going to use all this blank space to do our work. But where I have my box right here, you're going to do a little bit of writing about rounding and what we want to do on this problem. So you're going to want to write small, but everything that's on my next slide that's in the box, you're going to put in here. Okay, so you're writing this at the top right corner. All right, so let's look at this. So here's some information about rounding. It says if I am working the problem and get. So there's different situations we're going to get throughout our problems that we're about to work. I want to give you a second to write down everything that's in my rectangle at the top right of your paper. Now you might have to write really small, you might have to abbreviate some things, and that's fine. I'm going to give you a second to write it down at the top right corner. So now that you've written it down, let's actually talk about what this is saying. So if we're working out our problem and we get a decimal that looks something similar to this, so it obviously goes past the tens place, past the hundreds place, the thousands place, it's still going and going and going. If we get a decimal like this at any time in our problem, we're going to round that answer to the tens place. So that's totally the same as what it always is. So if we get something like this, we're going to round to the tens place. However, when we're working our problems, there will be times where we get answers that are cut off or terminated after the hundredths place. If it terminates after the hundredths place in our problem, we're going to leave that. So if it terminates at the hundredths place, we're going to leave this alone. We're going to leave it in the hundredths place. Don't round this. So I don't want to see 18 and 4/10. I want to see 18 and 35 hundredths. So if it looks like this, we're going to leave it. Then finally, anytime we solve for C, which is again the hypotenuse, you're always, always, always going to round to the tens place. So anytime, no matter what, even if it looks like this example or our top example, when you solve for C, we always, always, always round to the tens place. Okay, so let's go ahead and let's try this out. So on 109 still, let's go down and let's look at question 1. So if we look at question 1, again, we have a rectangular prism. This one is actually sitting vertically. The ones that we saw on the other page were horizontally, but this one is sitting vertically. And if we can notice, there's a diagonal line that cuts from the back corner, top back corner, goes down our shape and comes up here to the front corner. Our job is to figure out that distance, that length right there. Now, it's not as easy as just doing a squared, b squared, and c squared one time and we got our answer. So there's some more steps to this, okay? So the first thing we're going to do, and I want to see this on all of your problems, is we're going to do a little bit of shading. So in every problem like this that we do, there's going to be two triangles that we're working with. So there's two triangles, we're going to do two shading. So if you have highlighters or markers or different colors, you might want to use those. If all you have is a pen or a pencil, you're going to want to use just a different way of shading it, maybe color a different way or one lighter than the other. But we want to make sure we notice these two triangles. So the first triangle that we're going to look at is at the bottom, on the bottom floor, the bottom base of our triangle is this triangle right here. So I'm going to shade mine in with red. So you're shading in this bottom triangle with me. So there's a triangle down here at the bottom. We're going to shade that in. Okay, so there's our first triangle. The next triangle I want you to shade in is going to be a really big one on this shape. And I'm going to use a lighter color. So I'm going to use green, light green. So you're going to shade in this really big triangle here. So it comes down the back of it. It's got this diagonal line. And it meets up with our triangle that we shaded before. So I'm going to give you a second more just to get these two triangles shaded. Alright, so let's go through this and actually work one out now. So we're going to always start with the triangle that does not have the diagonal we're trying to find. So the one that has the diagonal we're trying to find is my green triangle. So we have to start with my red triangle before we can get to the green triangle. Now if we think about my red triangle, we know a couple things. We know that part of my triangle, one of the bases or one of the legs, is 6 inches. We know that. Now we know also this other leg over here. Okay? So that back part of my red triangle is the same length as this triangle here, this side here, which is 4 inches. So we're going to come over here by our red triangle, the leg, and we're going to write 4 inches. Alright, so let's look at what we have now. So we have 4 inches and 6 inches. And really, remember, this is like a rectangle, so we know this corner right here is actually 90 degrees, even though it doesn't look like it because of the angle. But we have a corner here that's 90 degrees. We have a leg that's 4 inches and a leg that's 6 inches. So we're trying to find this diagonal at the bottom. Well, we know that if we have legs, those are A and B, and we're trying to find what C is. Okay, so let's come over here to the left, and we're going to work this first problem out. So we're going to start with our two legs, which we know are 4 squared plus 6 squared. And again, we're just getting that from our red triangle on my screen. And that's going to equal c squared. Okay, so you guys help me work through this. So everybody, what's 4 squared? That should have been 16. Okay, you guys are going to help me out again. Everybody, what's 6 squared? That's 36. And that's going to equal c squared. So my next step is to combine like terms. So I'm doing 16 plus 36. So you guys again are going to help me. What is 16 plus 36? And we should have said 52. So 52 equals c squared. Again, you guys help me. What is the inverse of squaring a number? So I'm going to square root 52. Okay, so when we square root 52, again, anytime we solve for C, we talked about this, anytime we solve for C, we want to round to the tens place. So when we round to the tens place, we get this decimal right here. So I want you to turn to your table partner and say this decimal correctly without saying point. Go. All right, so we should have said 7 2/10. So what we just found, if we go back over to our shape, is we found this line right here that I'm going back over in black. So we found this side here. So we know that this side is 7, and we're going to mark this, and 2/10. So we just found that is 7 2/10. Okay, so now let's break down what we have. If we look at our green triangle, remember, our goal is to get this diagonal here. We now know what the base, or the first leg, of that green triangle is. And we actually already know this leg as well, the height. If we look over here, we know our rectangular prism is 10 inches. So we're going to take this 10 inches, we're going to rewrite it over here next to our green triangle. So I'm going to come over here, and I'm going to write 10 inches. And we know the height is 10 inches. So again, let's think about what we have. We know the height of the green triangle is 10 inches, and the base of the green triangle is 7 2/10, and we need to find this diagonal. Well, anytime we're trying to find the diagonal, remember, that is always C. So we're doing the same process again. We're just going to write it over here to the right. So again, we have A and B. So we have 10 squared plus 7 2/10 squared. And again, we're getting that from our green triangle only, and that's going to equal C squared. So now we're going to do some multiplication. So 10 squared, or 10 times 10. So everybody, what's 10 times 10? So we have 100 plus. So I'm going to give you a second. Go ahead and square 7 2/10. Okay, and when we square 7 2/10, we get 51 84/100. And again, I do not want you to round that to the tens place. I want you to leave it as a hundreds place, and that's going to equal C squared. Then I need to combine my constants, so go ahead and add those up real fast. So when I add those up, I get 151 and 87/100, and that's C squared. One more time, everybody, what's the inverse of squaring a number? So our last step is to square root our decimal. So 151 and 87/100 needs to be square rooted. So I'm going to give you that second. Do that. Remember, we always round C to the tens place. So go ahead and do that. All right, so on 3, let's say what we got. And again, we're going to say this the correct way. Ready? 1, 2, 3. So our answer for C should have been that 12 3/10 equals C. Okay, so if we go back to our picture, we've just decided that this diagonal right here is 12 3/10 inches, and we have now determined the diagonal in our 3D figure. So I want you to think about what we did, our process, for a second. So in our first triangle, we found C. So we solved for C. So on our red triangle, the first thing we did was solve for C. Once we had C, we came over here to the green triangle, and what do we solve for here? We solve for C again. So up above question number 1, I want you to write this because it's the same process every time. I want you to write solve for C twice. So really all we're doing in these problems is we're going to solve for side C twice. Every time, solve for C twice. Okay? So let's go through and let's look at another one together. We're going to kind of start it, and then you'll have a little bit of work time here. So let's try one more. Okay, so we're going to skip down to question 3. So we skip question 2 for right this second, and we're going to go down to question 3. So again, on question 3, we have a rectangular prism. We see again that we have a diagonal that's going down and to the right. So it starts at the back, it's coming to the front, down and to the right. We see again we have a measurement for this side, measurement for our width, or our depth, I'm sorry, going back, and then a measurement for our height. And again, remember, our goal is to figure out this diagonal right here. Just like last time, in order to do that, we're going to do a little bit of shading. So again, we have a triangle that's right here on the floor of our rectangular prism. We're going to shade in. So I'm going to take my color here, and I'm going to shade in the bottom triangle. Okay, so there's our first triangle shaded in. Then again, remember we have this other triangle that's kind of standing up in our rectangular prism. It's this section here. We're going to go ahead and shade that as well. Shade it a different color or a little bit lighter color if you're using the same writing utensil. Okay, so now that our two triangles have been shaded, remember we always start with the triangle that does not have the diagonal we want to find. So we want to find this diagonal that's kind of in my tannish color triangle. So we're going to start with my blue triangle. So again, we have one of the legs is 10 centimeters. We need to write down what the back part of this triangle, or the second leg, is. And again, it's the same as this side over here, which is 6. So we're going to come over here and we're going to label this section of our triangle as 6 centimeters. Okay, so again, what we have now is the two legs of my blue triangle, and I need to figure out the diagonal. Diagonal is always C, so I'm going to come over here and I'm going to set my problem up. 6 squared plus 10 squared equals C squared. So we've practiced this quite a bit. I'm going to give you a second. Go ahead and solve for C. All right, so let's go ahead and let's check our work with what I have up here. So we know that 6 squared gives us 36. We know 10 squared gives us 100. We want to combine our constants, our like terms, to get 136. Again, I need your guys' help. What's the inverse of squaring a number? So it should be square rooting. So we're going to square root 136, and we get this decimal. Turn to your table partner and say this decimal correctly for me. And our final answer for this C is 11 7/10. So remember, we take that number, and we're going to rewrite it over here on the side that we just found. So I'm going to go over it again in black so you can kind of see. So this side of our triangle is what we just located. And again, that's 11 7/10. Okay? So now we can use that side to figure out our diagonal in my tan triangle. So on our tan triangle, we know we have this bottom leg. Okay? We have the height, which isn't labeled on this side, but if we come over here, we know the height of our triangle should be 15 centimeters, since that's our rectangular prism height. So we're going to go over to our left side, and we're going to label that side as 15 centimeters. And now we're ready to solve. So again, we have a leg of 15 and a leg of 11 7/10. We're ready to find C, which is our other diagonal. So I'm going to go over here to the right, and I'm going to start to write my problem out. So it would be 15 squared plus 11 7/10 squared. And that's going to give me C squared. So again, I'm going to give you guys a second. Solve it all the way down and get what C should be equal to. All right, so now that you're done, let's go ahead and let's check our work here. So we know that 15 squared is 225. 11 7/10 squared gives us this decimal here, which I want you to turn to your partner and say it correctly. So the decimal starts with 136. Say that correctly. So it was 136 and 89 hundredths. We're going to combine our like terms to get this decimal here. Go ahead and say that decimal correctly. So we get 361 and 89 hundredths. Again, everybody, what's the inverse of squaring a number? So we're going to square root this. And we end up, once this rounds, it's kind of a weird one, it actually rounds up to 19 as a whole number. So our final answer for our side C is going to be 19 centimeters. And there's our final answer. And we have just figured out our diagonal line. So here's what I want you to do. I'm going to give you a minute here, and I want you guys to go down and work through question 5. So as me and Mr. Schrog are looking around, we want to see people who have shaded in the two triangles. You should have solved for C 2 times to get your answer. So I'm going to give you about 3 minutes here to try and solve number 5. Ready? Go. Okay, so now that you've had time to work, let's go ahead and check your answers with what I have up here. So again, I wanted you to shade our two triangles. So I have a triangle that's in blue and a triangle that's in purple. We need to start, remember, with the triangle that does not have the diagonal we're trying to find. So for me, it was my blue triangle. So I have my work over here, which ended up being 2 squared plus 2 squared equals C squared. Again, 2 squared gives us 4. 2 squared gives us 4. I combine my constants to get 8. Everybody help me out. What's the inverse of squaring a number? So we should have square rooted 8. Turn to your partner and say our decimal we should have gotten correctly. So we should have gotten 2 8/10. So remember, we put that as our leg of our big triangle. So I have 2 8/10 on the purple triangle. Since the height of our rectangular prism was 12, we know our triangle has a height of 12. So again, we're solving for c a second time. So 12 squared gives us 144. 2 and 8/10 squared gives us 7 and 84/100. And when we combine our like terms, we get this number here, which I want you to turn and say to your partner. So it should be 151 and 84/100. Finally, we square root, and we are left with this value. So go ahead and say this number to your partner. So our final answer for C should have been 12 and 3/10. So we need to come over here. My last step is going to be to write this 12 and 3/10, and we have a label of feet, and we have just found our diagonal. Okay, so let's go back and we're going to look at the even numbers now that are just a little bit differently. Then you'll have some time to work. All right, guys, so let's look at question number 2. We're going to do number 2 kind of together, and then you'll have some time to work on our last even numbers 4 and 6 on your own. And the reason we're going to do this together is because since the shape, our rectangular prism, if you notice, is laying horizontally this time, it kind of just changes a little bit of what we have. We're still going through the same steps. We're still going to solve for C twice. The only difference is just seeing our triangles. I want to make sure that we understand that. So remember, as we're looking at our rectangular prism, we have a diagonal that runs from the top down to the bottom. This other dotted line helps us out too because it's going to form our triangles. Again, we want to shade in the two triangles. So if we look, there's still a triangle that's on the bottom of our shape, our rectangular prism, and then there's this triangle in the middle that stands upright kind of, and that will be the second triangle that we shade. So I'm going to shade mine. If you're a little confused where we're shading, you can follow mine. But I'm going to start by shading my bottom triangle. So I'm really going to start over here by the 4 and shade down and then over. And then this dotted line forms my triangle. So I'm going to shade that in while you guys do it. Okay, so here's my first triangle. And then our second triangle that we're going to shade is the one that's kind of standing up in the middle of our shape. So I'm going to pick another color. And I'm going to go ahead and shade this triangle here. Okay, so now we have both of our triangles shaded. Remember, the same rules apply as last time. We're still going to solve for C twice, and we still want to save the triangle that has our diagonal line, which in my case is the purple triangle. We're going to save that triangle for last. So that means we're starting with our yellow triangle. So as we notice, our yellow triangle has a leg of 4 and another leg that's 8, and we're trying to figure out this hypotenuse. So just like last time, we're going to set this up as a squared plus b squared equals c squared, and for us that means it's 4 squared plus 8 squared equals c squared. Okay, so let's go ahead and do this together. If you're partner number 1, you're going to answer this question. So only partner number 1. What is 4 squared, partner number 1? And we should have said 16. All right, partner number 2. Everybody help me out. Partner number 2, what is 8 squared? And we should have had 64 for 8 squared. And again, that's going to equal c squared. We're going to add our two constants up to combine like terms, and 16 plus 64 gives me 80. And that is c squared. So everybody now, what is the inverse of squaring a number? All right, so if we don't know that the inverse is square rooting, we need to pay a little more attention. I feel like we've asked that question a bunch of times, so we're square rooting 80. I'm going to give you a second. Go ahead and find out what the square root of 80 is, and we're rounding to the tens place. So we should have gotten this decimal for C. Now I want you to turn to your partner real fast, everybody, and tell them how to say that decimal correctly. And again, that decimal is 8 and 9/10, and 8 and 9/10 is this diagonal line that splits our two triangles. So that's this diagonal line here is 8 and 9/10 meters. Okay, so again, we now go to the triangle that we want to find, which is this purple triangle that has the diagonal line. I have a leg that's 8 and 9/10, and I have another leg. The height of this triangle is 7. So I have A and B, and I'm going to use these two values to find C. So same steps. We're coming over here to the side, and I have 7 squared plus 8 and 9/10 squared equals C squared. I'm going to go ahead and just square these. So I'm going to give you guys a second here to finish this problem up. Go ahead and start. All right, so go ahead and check your work with mine. Our first step should have been to square 7 and get 49, and square 8 and 9/10 and get 79 and 21/100. Remember, we talked about rounding at the beginning. If they gave it to you as a hundredths, we want to leave it like that. When we combine our like terms, we get 128 and 21/100. We know the inverse of squaring a number is square root. When you square root 128 and 21/100, you end up with this decimal here. Everybody turn to your partner and tell them how to say this decimal right here. And we know that our final step is to write it over here into our diagram. Our rectangular prism is 11 3/10 meters, and that is our final answer. All right, so what I want you to do now is go ahead, use these examples we've done, and go down and do questions 4 and question 6. And then we'll come back and check them, 4 and 6. Okay, go. So now that you have had time to work, here's what I want to have happen. Partner number 1, you're going to go through and you're going to explain all your steps on number 4 all the way through to your answer. So partner number 1 has question 4. Partner number 2, you're going to go through and explain all of your steps on number 6. And then once both of you guys have had time to explain, we'll go back and I'll just show you the answers and we'll check how we did. Okay, so start explaining. Go. Okay, so now that you've partner shared, let's go ahead and let's check our last couple answers here. So here is the work we should have had for question 4. Instead of me reading through it, I'm going to give you a second to go through it and check your work. All right, and let's move on to question number 6. And here are our answers for question number 6. Go ahead and check that one. All right, so I know this was a 2-part video, but we have now met our objective for the day, which was we were going to find the distance between 2 points and use Pythagorean Theorem on a coordinate plane. And then we were going to use Pythagorean Theorem on 3D figures or rectangular prisms. And now it is time to do some more practice. Good job, guys.